The Earth's climate is a complex system influenced by many factors. One significant factor is the Milankovitch cycles. Welcome to the Avalon lab. Today we will be discussing these cycles and how they affect climate. These cycles describe how Earth's orbital and rotational parameters vary over time. They impact the distribution and intensity of solar radiation received on Earth. The Milankovitch cycles include three main components: eccentricity, axial tilt, and precession. Each cycle operates over different timescales ranging from tens of thousands to hundreds of thousands of years. These cycles, individually and collectively, drive long-term climate changes. And so, understanding Milankovitch cycles is crucial for unraveling past climate variations. It also provides insights into potential future climate trends. By studying these cycles, we gain a deeper understanding of Earth's climate system and its intricate workings. Eccentricity, stretching Earth's orbit. Eccentricity refers to the shape of Earth's orbit around the Sun. Earth's orbit is not perfectly circular but slightly elliptical. This elliptical shape changes over time, becoming more or less elongated. The eccentricity cycle has a period of about 100,000 years. When the orbit is more elliptical, the Earth receives less solar radiation at its farthest point from the Sun, known as aphelion, and conversely it receives more radiation at its closest point, known as perihelion. These variations in solar radiation influence Earth's climate. A more elliptical orbit can lead to colder periods during aphelion and warmer periods during perihelion. However, the overall effect of eccentricity on global average temperatures is relatively small. Earth's wobble or axial tilt is also known as obliquity, refers to the angle of Earth's axis of rotation relative to its orbital plane. This tilt is currently about 23.5 degrees. However, this angle varies between 22.1 and 24.5 degrees over a period of approximately 41,000 years. Changes in axial tilt affect the distribution of solar radiation across different latitudes. A larger tilt angle leads to more extreme seasons with hotter summers and colder winters. Conversely, a smaller tilt angle results in milder seasons. The axial tilt cycle plays a significant role in driving glacial-interglacial cycles. A larger tilt angle can contribute to the initiation of ice ages by promoting the growth of ice sheets in high latitudes. Regarding Earth's top-like motion or axial tilt, precession refers to the slow wobble of Earth's axis of rotation. Imagine a spinning top. Its axis wobbles in a circular motion. Similarly, Earth's axis wobbles, completing one full cycle approximately every 26,000 years. This wobble affects the timing of seasons relative to Earth's position in its orbit. Currently, Earth is closest to the Sun in January, known as perihelion, and farthest in July, known as aphelion. However, due to precession, these timings will gradually shift over thousands of years. Precession can enhance or dampen the effects of eccentricity. If perihelion coincides with summer in the northern hemisphere, it can lead to warmer summers and milder winters. Conversely, if perihelion coincides with winter, it can result in colder winters and milder summers. NASA researchers have found that the Milankovitch cycles, which describe changes in the Earth's orbit, cannot entirely account for all climate variations that have taken place over the last 2.5 million years. Moreover, they are unable to explain the current abrupt warming that Earth has undergone since the pre-industrial period, especially since the mid-20th century. Scientists are confident that the recent warming of Earth is mainly caused by human activities, such as the release of carbon dioxide into the atmosphere from burning fossil fuels. Milankovitch cycles operate on timescales that range from tens of thousands to hundreds of thousands of years. However, Earth's current warming has taken place over much shorter timescales of decades to centuries. Over the last 150 years, Milankovitch cycles have not significantly impacted the amount of solar energy absorbed by Earth. In fact, NASA satellite observations show that solar radiation has actually decreased somewhat over the last 40 years. It's also important to note that Milankovitch cycles are just one factor that may contribute to climate change, both in the past and present. For ice age cycles, changes in the extent of ice sheets and atmospheric carbon dioxide have played crucial roles in driving the degree of temperature fluctuations over the last several million years. Discover more about the Earth, sustainability, environmental protection, and risk management at theavalonlab.com. Join us in our mission to understanding the world.